So, the p orbitals can exist on, okay, you're allowed to sit down if you want. You don't have to, but you have to sit in the back if you want to stand for notes. The x, the y, the z. So, we can have three orientations of the p orbital. Guess how many p orbitals we have? 3! Because guess what? They're oriented on the x and the y, and I always draw this one like a lazy 8, and the z. So we have 3 p orbitals because they're oriented every way they can possibly be oriented. The x, the y, and the z. Get those out of there for now. Okay, now, in each of those orbitals, how many electrons can we have? Hold up your fingers. 2! Good, you got to catch on quickly. I like this. I like this a lot. So, in this s orbital, we have 2 electrons. In this p orbital, we have 2 electrons, 1 up, 1 down. Here we have 1 up, 1 down. Here we have 1 up, 1 down. Doesn't matter where we draw them because we don't know where they are anyway. And Heisenberg, do you know how fast you were going? No, but I know what I am. Okay. Comes for science. Oh, I forgot to put my P shape in for my section. There. Okay. So, I would like you to take a moment and very carefully think about whether or not you are seeing any patterns.
Yes.
Okay, I have 1 yes and 2 adamant no's.
For the 2 is you got 2 things in this.
Aha!
Player 2.
Yeah, who would
Okay.
have thought that?
So, the number n for my energy level. It seems so far that I have the same number of shapes or sublevels. So for the third main energy level, I would like you to write down your prediction. How many shapes do you think we're going to have? 3! You guys are bad at writing down your prediction. That's okay. Yeah, we're going to have 3 shapes. Okay, well, once again, everybody gets an S. You're not that special. So, third energy level gets an S. What else would they have? They've got a P. Everybody except 1 gets a P. Well, then things get interesting. Dun, 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 dun. This is what I call the double dumbbell, the double drumstick. I sometimes call it the double. This is the double drumstick. Yeah. This is the double drumstick, or the double drumstick squared, or double dumbbell. It's awful. But what you need to know is that that's a d orbital. This is called d. So, how many ways can you think of to arrange that d orbital? So first of all, let's draw in the d for sublevels. And we always use lowercase letters on these, never uppercase. So are there any other patterns you've noticed? Okay. What? Okay, every energy level we get a new orbital. So we had 1 way to arrange an S. We have 3 ways to arrange a P. How many ways do you think there are to arrange a D?
6.
5.
I was going to say that too.
That's okay.
Oh, I get it. I see. 6 plus 2.
Yeah. So we have the this is the double drumstick donut. I should have saved that one for last. So we've got the d orbital with its arms and legs on the x and y axis. We have the d orbital with its arms and legs on the x and z axis. We have the d orbital that said, oh, forget this, I hate the Cartesian coordinate system, I'm just going to mess with them now and do jumping jacks. We have the d orbital that got really tired and had to lay down.
How do we draw that?
I'll show you. And then, you know, there's always a little oddball in every family. Maybe you're the oddball in your family. I don't know.
Yeah, if you don't know who the oddball is,
It's probably you. Yeah, because I'm like, oh, we don't have an oddball in my family. That's what they keep telling you. So then we've got the real oddball in this family, which is the double drumstick donut. Who thinks of these things? Schrodinger's wave equation thinks of these things. So we'll put that up there. Okay. Am I all off screen now? Yeah. So we have 5 different ways to arrange a D. So let's draw in, these are all the actual orbits we've got. So we have how many S's? 1 S. How many P's?
3.
3. Those are not very well drawn. How many D's? 5. Okay, this is where it gets weird. So I always do 1 straight up, 1 on a slant, 1 facing out, 1 laying down, and then I draw the double dumbbell donut. Yeah, that's good as going to get. They're pretty ugly. That's okay. So in terms of individual electrons, we have our S with 1 up, 1 down. We have 3 P's, each with 1 up, 1 down, 1 up, 1 down, 1 up, 1 down. We have our 5 D's. 1 up, 1 down, 1 up, 1 down.
Do we have to rewrite the P's, or can we just rewrite this?
I would rewrite all of them. So 5 D's, 1 up, 1 down. So let's stop 1 moment here and do some counting. So, on the first main energy level, how many different shapes do we have? How many subshells exist? 1. On the second main energy level, so I'm going to write here, number of subshells. So number of subshells, 1. On the second main energy level, how many subshells do we have? 2. On the third main energy level, how many subshells do we have? 3. Very good. You got a prediction for the fourth main energy level, number of subshells? What do you think? 4. Okay. We'll get to that in a minute. So in terms of orbital orientation, how it's arranged, and therefore how many actual orbitals we have. On the first main energy level, we have how many? 1. On the second, we have how many? 1, 2, 3, 4. 4. So this is number of actual orbitals. On the third main energy level, how many do we have? 9. Okay, I'm not going to say anything else. I'm not going to ask you for a prediction just yet, because we're going to keep walking through this. So, on the first main energy level, how many actual electrons do we have? They're easy to count. They're the big arrows. 2. On the second main energy level, so this is actual number of electrons. On the second energy level, how many actual electrons do we have? 8. On the third main energy level, boy, they're hard to count. How many electrons do we have? Interesting. Okay. So, now let's talk about the fourth main energy level. Let's take a break from numbers. So on the fourth main energy level, N equals 4. So that's our first column. And you guys already predicted there would be 4 shapes. So we've got our familiar S, our familiar P, our D, and then we have F. So I'm going to quote the Ohio Academic Content Standards regarding quantum numbers and the shapes of orbitals above the p orbital. The shapes of orbitals D, F, and G are outside the scope of this class. They're weird, folks. I will get pictures. I'll pull up some images online. Somebody's got nice computer-generated images of those F and G orbitals. I can't even begin to draw them. They're funky. So, no, that's what I do for them. That's what I do for F. Yeah, well, you know, they're cheating you, clearly. So, how many ways do you think there are to arrange that squiggle?
7.
So, based on the actual geometry of the squiggle, you really can't tell, can you? Because I just gave you a bunch of spaghetti. But you think 7. Why do you think 7?
Because it would equal 16 every number. Hold on.
Okay.
The main energy level square.
You're way ahead of yourself. Yes, you're like 3 steps ahead of everybody. Good, good. That's awesome.
The main energy level squared is the number of orientations. I just caught that.
Okay, so
And then times 2.
the orientations for an F orbital, there are 7. Don't shout that out yet, because everybody's going to have to figure that out on their own. Okay, so for actual number of orbitals, well, we've got 1s, we've got 3p, we have 5d, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the suspicion, which is correct, the prediction is that we would have 7 F orbitals. Well, guess what? We have 1, 2, 3, 4, 5, 6, 7 F orbitals. I'm just drawing a random squiggle. It's not actually a shape. It's just a scribble. Now, come to think of it, it's hard to tell apart from the G's, isn't it? Sorry. So, how many actual physical orbitals do we have there? 16. Which you can get by counting. You can get it a couple different ways. Now, for electrons, oh man, do I have to draw this? Yes. 1 up, 1 down, 1 up, 1 down, 1 up, 1 down, 1 up, 1 down. And the D's. I'm going to try to draw my D's neater, that's my goal. And 1 up, 1 down, 1 up, 1 down, 1 up, 1 down, 1 up, 1 down, 1 up, 1 down. And my F's, 2, 3, 4, 5, 6, 7. 1 up, 1 down, 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 1 up, 1 down. How many electrons do I have there? Bunches.
36.
Heard the right number yet?
32.
32? Why do you say that, ma'am? Because every orbital can hold how many electrons? You have 16 orbitals. How many electrons can you have? 2 times 16. Good job. Okay, so I'm going to have you quietly for a moment look for mathematical patterns And I'm gonna shut off this recorder.